Okay, we are doing section 4.4, which is finding slope and rates of change. So what is slope? Slope is the ratio of the rise, which is change in our y value, to the run, which is the change in our x value. The equation that talks about what I just described is rise over run, which is the change in y over the change in x. And slope is always given by an m. So change in y is represented by y2 minus y1 over x2 minus x1. On a graph, we have a line. And we have 2 points. Our first point from left to right is x1, y1, and our second point is x2, y2. So knowing that, this is our rise, and this is our run. Vertical is the rise, horizontal is the run, and the run is you find by doing x2 minus x1, that's the difference of the x values, and rise you find by y2 minus y1, difference of the y values. Most important thing to remember when you need to know what slope is the formula for slope, which is y2 minus y1 over x2 minus x1. Okay, now we have an example. Find the slope of the line shown. First, we should probably figure out what these points are. This is -4, 2, and this is 2, 6. So we can even count when we have a graph like this. We can say, okay, what's our rise? 1, 2, 3, 4. What's our run? 1, 2, 3, 4, 5, 6. It's rise over run. And we can show that using our formula. Y2 minus y1 over x2 minus x1, which is 6 minus 2 over 2 minus -4, which is 4 over 6, and we need to simplify when we have slope. This is 2/3. Okay, so now we don't have an actual graph, we just have the points, so we need to find the slope of each line. So y2 minus y1 over x2 minus x1 is going to give us a 3. 6 minus 3 over 4 minus -2. It's going to give us 1/2. Just a quick note, we do not write fractions. We do not write slope as decimals. They have to be fractions. -3 minus 5 over 1/2 minus 9/2. Simplify, it comes out to 2. So if you were to write part B as 0.5, it would be wrong. You need to write it as a fraction because that helps us figure out what rise over run is. We know that rise is 1, rise is 1 and run is 2. So we wouldn't have known that if it was just 0.5. Okay, same thing. First we need to identify what these points are. This point is 3, 5. And this point is 6, -1. So let's use the slope equation. -1 minus 5 over 6 minus 3. -6 over 3 is -2. Okay, let's do this one. Figure out what these 2 points are. This is -2, 4. and 4, 4. So we need to figure out what the slope is. We do y2 minus y1, 4 minus 4 over 4 minus negative 2, 0 over 6. So our slope is 0. So it's a good thing to note right now that every time you have a horizontal line, your slope is going to be 0. Now this time we have a vertical line. This point is 3, 1. This point is 3, 5. Try to find the slope of that. Let's go from bottom to top. So our top would be our second point. So we would have 5 minus 1 over 3 minus 3. 4 over 0. Now if we have 4 divided by 0, that is actually not 0. That's not anything. That's undefined. So 0 on the bottom is undefined, so the slope of any vertical line is undefined. But if you have 0 on top, that would be a horizontal. That would be 0. Okay, let's find the slope of these lines. Negative 2 minus 2 over 5 minus 5. That's undefined. Four minus 4 over negative 3 minus 0. 0 over negative 3, 0. Negative 4 minus 6, 5 minus 0. Negative 10 over 5, negative 2. All right, we're going to do some classification of lines by their slope. The first one has positive slope. The graph rises left to right. The second line has negative slope. It falls from the left to the right. And these last two we kind of just talked about. If we have a line like that, this is a 0 slope. That's called a horizontal line. Anytime that you have a 0 slope, you have a horizontal line. And the fourth one, that's undefined slope. That would be a vertical line. Okay, now we have the rate of change when we're talking about word problems here. The rate of change is always going to be given by the change in cost over the change in time. The table shows the cost of using a computer in an internet cafe for a given amount of time. Find the rate of change in cost with respect to time. So we pick 2, and we find the change in cost over the change in time. Change in cost, we go 14 minus 7, and the change in time, 4 minus 2. Change in cost is 7, change in time is 2, which is 3.5, or $3.50 an hour, because we were dealing with dollars per hour, so we do need to simplify it in terms of that. The community theater performed a play each Saturday evening for 10 consecutive weeks. The graph shows, or our points show, the attendance for the performances in weeks 1, weeks 4, 6, and 10. Describe the rates of change with respect to time. So we're going to do each one. We have to do week 1 to 4. Let's do that one first. Change in attendance, it'd be 232 minus 124 over 4 minus 1, 108 over 3, so that's 36 people per week. Next one we need to do is the change between 4 and 6. (204 minus 232 over 6 minus 4), negative 28 over 2, which is negative 14 people per week. And last one, from week 10 back to 6, that's 72 minus 204 over 10 minus 6, negative 132 over 4, that's negative 33 people per week. Describe the rates of change in attendance with respect to time. So it obviously was increasing in those beginning weeks. It decreased pretty slowly at 14, and then it started decreasing more. Okay, so if you were to describe this and you just said it went up then went down, I don't think I would think that was an adequate answer. You need to be a little bit more specific in when you're talking about rates of change. A student commutes from home to school by walking and riding a bus. Describe the student's commute in words. So we have 3 different segments here. I'm going to call that segment 1. We have segment 2. And the last part is segment 3. So when I'm talking about that first segment, it looks like he's not going that fast. It's not very steep. So he must be walking if we're talking about his commute. The second segment, this is obviously horizontal, so this is a 0 slope. So he's not moving at all. He's got to be waiting for his bus there. And the third segment, if you compare the different speeds between segment 1 and segment 3, this is very steep, which means he's going very fast. Here he's riding the bus. Obviously buses can travel faster than walking, so segment 1 should be a little bit shallower than segment 3. Okay, and that was section 4.4, Introduction to Slope.